Okay, so on the second part of the notes that you're going to get for section 5, this should be 4.5 right here. So in the second part, what you're looking at is you're looking at some different formulas. One is the procedure for Newton's method. It's this very first guy right here. It's really an interesting thing, and it's not too complicated actually. You just have to make a guess to start with, and then get going, and we'll see how that works. Differentials are these two guys right here. Notice that this first one is just the derivative of a function, and then you move the dx over, and this guy right here is the same thing, except we're looking now at a specific value for x. And then down here is just looking at your different values for change, absolute change, relative change, and percent change. So we're going to look at all of these things. And notice that, though, these two guys are really, really, really closely related. Okay? Just basically a derivative, and you multiply both sides by the dx part. All right, so Newton's method. How can you solve Newton's method? Well, what you need to start off with a function, and we're going to need the derivative of this function. So if this guy is f of x, then I need to know what the derivative of that is. And in this case, it's going to be 3x squared plus 3. And then once I know that, I'm just going to follow the formula, which is really a kind of a goofy looking formula. X to the n plus 1 is equal to xn minus f of xn divided by f prime of xn. And kind of like linearization, this is going to be where we just look at a formula, and we're not going to deviate too much from our formula. And so basically for this particular problem, what this is going to boil down to is xn minus x cubed n plus 3xn plus 1 over 3x squared xn squared plus 3. And all that n represents is like the number that we're looking at, like the first time through, the second time through, the third time through. So it's really not it's not a painful, horrible ordeal. So what we want to do is we just need to pick the first x, 1, xn. And what I would recommend is that you just graph this guy, graph x cubed plus 3x plus 1, put it on your graphing calculator, and find where it crosses the x-axis. And one of the places that it crosses the x-axis looks like it could be pretty close to negative 0.3. And you can even just rough eyeball that if you want to, and just take your best guess. It's not a super big deal. We just run it through the formula now. So what do? You go negative 0.3. That's my end part, minus, and then you go negative 0.3 cubed plus 3 times negative 0.3 plus 1 over 3 times negative 0.3 squared plus 3. And you plug that into your calculator. And when you run it into your calculator, you're going to get the next term out, which is going to be x2. So if you punch this all into your calculator and you punch it all in correctly, and we want to carry through a few decimal places, what you're going to end up with is negative 0.322,324,159. And then store that number in your calculator, or write it down so you've got it, or save it, or whatever. And then you're going to take this number right here, this big long nasty decimal. We want to keep as many decimal places as possible, and you're just going to put it right back into this problem right here. And you're going to take the exact same steps. So it's going to be negative 0.322324159 minus that number cubed plus 3 times that number plus 1 divided by 3 times that number squared plus 3. And when you do that, what you're going to end up with is your third number in your series, which is going to be negative 0.32218 53603. And what you're doing is you're approximating the zero for our cubic function. You're approximating this zero. And if we were to continue going, once we go to like the fourth one, once we go one more time through this process, you're going to have a zero that's really, really close to the value that you want. And so this is called Newton's method. It's really kind of a cool deal. And there's a couple tips and tricks you can use on your calculator as well. And we'll look at that actually in class. But all it is just a process where you're just going to perform the same steps over and over. And you're going to start with your function. You're going to start with your function. And you're going to divide your function by your derivative. And then you're going to start with a guess, which in this case we took negative 0.3. And then you're off and running. Okay, so we want to find dy. This is not hard at all. So dy dx equals 5x to the fourth plus 37. Hey, oh, by the way, x is 1, dx is 0.01. So all you're going to do on that then is you're just going to get your function to look like a differential, which is going to be dy equals 5x to the fourth plus 37 times dx. And then you're going to take x and plug it in where you see an x. And you're going to take dy or dx and plug it in where you see dx. And that's it. That's all you have to do on these types of problems. So dy is going to be equal to 5 times 1 to the fourth plus 37 times 0.01. And when you punch that into your calculator, you're going to get 0.42. Okay, not a hard, horrible, difficult thing. You're just looking for a derivative. Same thing with the sine cubed. Same thing with sine cubed. So when we look at sine cubed of, sine of 3x, then you just take the derivative of that. So dy dx equals the derivative of sine, which is cosine 3x times 3. So there's your derivative, and then we're just going to change it so that it's a differential. dy equals 3 cosine 3x dx. And then, oh, by the way, x is pi, dx is negative 0.2. So we just substitute those guys in. And we're going to say that dy equals 3 times cosine of 3 pi times dx, which is 0.02. Ran out of room. And when you punch this into your calculator, which you'll need to punch this into your calculator, we know the cosine of 3 pi, that's going to be negative 1 times the 3, but you might just want to double check yourself and make sure that you're right, but you should end up with 0.06. Alright, so those guys are pretty simple for the most part, pretty straightforward. Just take a derivative and substitute in what you know to find what you don't. Okay, what about one that looks like this? X plus y equals xy. Well, we've got to use the chain rule, or not the chain rule, the product rule. So when we take the derivative, then the derivative of x is 1. The derivative of y is dy dx equals, and then this, you got a product rule, this guy. This is x times y. We got a product rule. It's going to be implicit differentiation. So it's the derivative of the first times the second plus the first. I took too many derivatives here. This should be the derivative of the first times the second plus the first times the derivative of the second. And so before we can get the dy all by itself, we've got to get the dy dx together on one side of the equation. And so what I'm just going to do is I'm just going to subtract x dy dx from both sides. and I'm going to add the 1, or subtract 1 from both sides. So what this is going to give me is going to be the problem then that I can, well, I'll just show you. It's going to give me this. It's going to give me dy dx minus x dy dx equals y minus 1. And now I can factor out the dy dx part. And so what is my what is the differential equal to? And so what we would do is we would just divide both sides by the 1 minus x and multiply by the dx. So whoops, 1 minus x. And then multiply both sides by the dx. And so my differential is going to be dy equals 1 minus x over, what gee whiz, 1 minus y. Y minus 1 over 1 minus x dx. And then we can substitute in all the stuff that we know. Well, what is y? That's the first thing. We'll go back to your original problem, and you have to figure out what the y is equal to. And so the way that we do that is we just take this 2 right here and substitute into our original problem. So this is a two-stepper. So back to my original problem for just a second. I'm going to let 2 plus y equal 2 times y. And I get the y's together on one side. And so this is going to be 2 equals y, 1y. And so now this is what my y value is right here. And here's my x value right here. And here's my dx value right here. So I'm going to end up with a problem that's going to look like y minus 1, 2 minus 1, over 1 minus x times 0.05. And when you get done with all that, that should end up equaling, and this is dy by the way, so dy would equal negative 0.05. So a few more steps on that one, but not horrible. Just slow down and pay attention and use what you know to find what you don't. Okay, another couple of finding differentials of functions now. So if you see something where it says d tan 2x, then you're just basically going to take the derivative of that function, and you're going to finish it with a dx. Notice that there's no d dx on this guy. So the derivative of tangent is secant squared. So we're just going to have secant squared 2x times the derivative of the 2x, which is 2, dx. So secant squared 2x times 2 dx. Well, what is that? That's 2 secant squared 2x dx. That's your differential for that guy. That's all there is to it. It's not a horrible, overly complicated deal. What about the d of x over x plus 1? Well, you can do this two different ways. You can pick it, but maybe if you like the chain rule, or if you like the quotient rule, you can do the quotient rule, and if you like to do the product rule, you can do the product rule. It's kind of up to you, but it's going to be the derivative of the top times the bottom, or I'm sorry, the bottom times the derivative of the top, so x plus 1 times 1 minus the top times the derivative of the bottom all over the bottom squared. And so when you get done with this, you're going to have x plus 1 minus x over x plus 1 squared. And so what is that? And don't forget, by the way, there's a dx at the end on both of these. So what are you going to have for your final answer? Just 1 over x plus 1 squared dx. And that's all there is to it. We're just taking a derivative, and that's all. Okay, on this guy, what we want to do is we've got this circle, and the radius r of a circle increases from a, which is 10 meters, to 10.1 meters. Use dA to estimate the increase in the circle's area a. Compare this estimate with true change, delta a, and find the approximate error. Looks long, looks nasty, not bad. Let's start with what we know. We know that the area of a circle is pi r squared. Okay, and we know that the radius of the circle in this case is 10. And we know that the radius of the circle increased from 10 to 10.1. So that's the change in r. That's r. And how much do we change by? We changed by, 0.1. We changed by 0.1 because we went from 10 to 10.1. So we've got r, we've got dr, and so let's go ahead and take a derivative of this. So we would have dA dr, because those are two variables, is equal to 2 pi r. And then since we're talking about differentials now, we're talking about the change in the area is equal to 2 pi r times the change in the radius, dr. Well, looky here. We've got a radius. We've got a change in the radius. So we just plug in those two numbers. It's not too tough. So I got 2 times pi times the radius times the change in radius, which is 0.1. Punch that into your calculator or leave it in terms of pi. Either way, I like terms of pi, and you get 2 pi meters squared. That's all there is to it. So true change then. True change is just the difference of the differential which we found and the area, or actually the true change is the actual change in area of the two things. So we would take our area formula, again this guy right here, we would take our area formula and we would substitute in 10 and 10.1. So what we would have is our true change, the actual true change, okay, would be pi times r squared, and we'll take the larger radius, pi r squared, minus pi times the smaller radius. And so this is going to be 102.1 pi minus 100 pi, which is equal to 2.01 pi meters squared. Okay? So that's the actual physical, real change, not like an estimated change. And we found that estimation in that first problem that we did. So then to find the approximate error, then all you're going to do is take your actual change minus your estimated change, so 2.01 pi minus 2 pi, and that's going to be equal to 0.01 pi meters squared. And that's all there is to it. Don't let this stuff be overly hard. And again, you'll have to work a couple at it, to get into a flow, but they're not bad problems to work out. They're not too horrible to do.